Hello guys, in this session I'm going to cover an important part of A1 kinematics from exam point of view. There are a lot of people who actually face problem when it comes to questions on projectile. So here in this session I'm going to explain you like how one can easily solve questions on projectile's motion. Before we actually start this particular part of projectile, I hope everybody is aware of the Suvat equation which we have learned earlier. So if anybody is not aware of those Suvat equation, let me tell you. The first three Suvat equation which we need to know, that is V is equal to U plus AT, S equal to UT plus half AT square, and then we can say V square is equal to U square plus 2AS. Sometimes people add the fourth one also, which is basically a distance formula where you use average velocity into time. Okay, and they say this is like 4 Suvat equation, but the main Suvat equation are the first three which I've written, because if you notice in all three we have something common. They all have acceleration present in them. Now projectile motion, basically every single projectile motion can be solved with the help of a Suvat equation. That is something which we are going to see when we go deep into the discussion on projectile motion. But first you need to understand one thing, that when it comes to projectile motion, there are three types of questions which usually the examiner asks you. The very first case, it's a classical case of projectile motion where you can say that an object has been thrown with a certain speed, with a certain angle from the ground, and this is how the motion is going to be take place. The other case which we can discuss here is the part where you are standing on some cliff of a certain height given as h, and you project a body with a horizontal velocity u, which is basically also called as horizontal projection. The third case which I can include over here, it is something which is the extended part of the case B, where again you are standing on some cliff. The height of the cliff is given as h, and here you actually throw something with a certain angle with the x-axis. So this is how the motion is going to be look like in this particular case. So the moment you see any particular question, whether it is case A or whether it is case B where the body has been horizontally projected, this is how the three motions are going to be look like. Your aim will be very simple. The moment you read the question, you should be able to identify that in which particular category your question falls. Okay, now look here. Now basically when you have to do a question on projectile motion, the very first thing which you will do, you will read the question and you will figure it out that in which particular category or the case your questions falls into. Now here you can see that suppose if the question falls into our case A, we should be able to comment on some certain values. We should be able to comment on some certain values, like I should be able to comment that what exactly is my initial velocity, which is on x-axis and y-axis. I should be also able to comment like what is my displacement, which I have on x-axis and y-axis. Then I should also be able to comment that what is my acceleration going to be on x-axis and y-axis. And the last thing which I can put under this column is time. So when it comes to the classical case of projectile motion, where you can see that object has been projected with a certain angle from the ground, we know that we have to take help of resolving, and the component which is adjacent to the theta can be written as u cos theta by drawing this component, and the component of velocity which is opposite to theta can be written as u sin theta. There are a few more information which I wanted to keep it over here, like this is your h max, and there is a certain distance which the object has covered on the ground. Let's say we call it as a range represented by r. Now when I look at this particular chart which I have drawn over here, I can say that if I have to write my initial velocity on x-axis, what it is, u cos theta. My initial velocity on y-axis is what, it is u sin theta. My displacement on x-axis, if you notice the above diagram, it is nothing but it is the range which can be written as r, My displacement on y-axis, this is one interesting thing, because you can see that we are saying displacement on y, means I can see that the object has moved h max up and then it has come down. While going down, you have to put a negative sign because we are talking about displacement, so we have to take care of the plus or minus sign. So I can see that here the distance traveled up and the distance traveled down is same, so the displacement value in this particular part under y-axis is going to be 0. The third thing is acceleration, where we know that acceleration, when we define on x-axis, we do not consider the effect of resistance on the motion of the body, and that is one of the reasons that your velocity on x-axis is going to be constant. And that is the reason when somebody says what is the acceleration on x-axis, make sure it is taken as 0. On the other side, when you go for acceleration on y-axis, we know that when it is moving on the y-axis, it is moving under the influence of gravity. And because of that, what will happen? Initially, your velocity will decrease. At the maximum height, your vertical component of velocity is going to become 0. And then after that, yes, it will change its direction. And when it hits the ground, it will have the same component of velocity, which is going to be here. So when I'm writing the value of acceleration, make sure it is downward, the acceleration due to gravity. So we are writing it as a g. There is one thing which is very interesting over here, which is written last in the column, which is time t. And let me tell you, time is your best bet whenever it comes to the projectile motion. Why? Because it is something which is going to be remain same on x-axis and y-axis. So suppose if I am able to calculate the value of time from the y-axis, I can place that value on x-axis, or if I able to calculate the value of time from x-axis, I can use that value of time on the y-axis as well. So that is one thing which is very important, and most of the time it happens that the very first thing which you can calculate when it comes to projectile motion case is the time. Let's move on to the second case, which is a case of horizontal projection. Again, we are interested in certain values, which I will say, like, we are again interested in the initial velocity on x-axis and y-axis. So I'm writing this is x, this is y, this is my initial velocity, this is my displacement, this is my acceleration, and this is my time. Now again, if you notice the above case, remember there is a certain distance which you have covered on the ground, which you can write it as again range, the distance covered on the ground. You can say this is height of the cliff has been given as h. Be very careful, it is a case of horizontal projection. So usually in the numerical you will read this term that it is a case of horizontal projection. So we need to understand certain thing, that because of air resistance is negligible, my velocity on x-axis is not going to be changed, and we consider air resistance as negligible. But as g is present on the y-axis, my initial velocity on the y-axis is definitely 0. Why? Because the body has been projected horizontally. But as the body is moving on the y-axis, you will find there is some certain value of y will exist, and that value will keep on increasing. It depends on like how much time the body stays in the air. Now if I have to write the initial velocity, be very careful. On x-axis it is given to you as u. When you go to the initial velocity in y-axis, it is 0. So for a case of horizontal projection, we can take the initial velocity as 0. At the same time, when you talk about displacement on the x-axis, again I will say it is r, which is my range. My displacement on y-axis in this case, if you notice, my body has traveled a certain distance down, and as I'm saying displacement, make sure the displacement on the y-axis is nothing but it is traveled in the downward direction. That's why I'm writing it as minus h. You have to be very careful with the sign over here, because remember these quantities are vector quantity, and we have to give the sign because it represents the direction of that particular motion. When I go for the acceleration on the x-axis, again we said the velocity on the x-axis is going to be constant, so it is 0. On the other side y, yes, it is minus g. And again in this part of question also, the best bet on which you can do questions most of the time, this is the first thing which you can calculate. because the value of time can be calculated from any of the axes and it can be used on the other axis values also. If you go for the third case, it's a combination of A and B. If you notice, that means I have given a certain angle with my initial velocity. So the first thing which I will do, I'm going to resolve it and I'm going to get my component. So adjacent is cos, vertical is sine. Then in this case, I am defining there is a certain height from the cliff, which I'm writing it as small h, and max, because this is my maximum height from the cliff. Motion happens in this way, and we know that it is also again happening under the influence of gravity, so which is present everywhere. Again, when we do the question, we are interested values on the x-axis, y-axis. Again, we need to comment on what is my initial velocity on x and y, what is my displacement on x and y, what is my acceleration on x and y, and the last thing again comes in this column is time. Now looking at the situation, what we can comment? We can simply say that my initial velocity which I have on x-axis, this is what? It is u cos theta. Y-axis, it is u sine theta. My displacement on x-axis, yes, certain distance covered on the ground. Again, if we have to give it any name, we can say it is a range, so I'm writing it as r. What about my displacement of the y-axis? Now here you have to be careful because you are going h max up, then you are coming h max down, and then you are again traveling the distance which is height of the cliff, which is written with a minus sign. I know that these two things are going to get cancelled, just like the case A. So the only thing which will be your displacement for this complete journey from the cliff to the ground is going to be minus h. Again, be careful with the sign because again the terms are vector quantity. You have to be careful with your negative sign. When it comes to the acceleration, I'm writing the value of acceleration on the x-axis is 0. On the y-axis, again it is minus g. And again, your best bet is to calculate the value of time, let it be from x and y, and we can use that particular value on the other axis because it is independent of your axis. Now, if anybody has to remember anything when it comes to projectile motion, this is something which you need to remember, where the moment we read the question, we have to identify like which exactly the case we are talking about, and after that you should be able to relate with the value which are present on x-axis and y-axis. Let me give you a simple example. Let's say if we have to find the time of flight in the first case. So if I have to write the time of flight, which is basically the time taken by the object to reach or to go from point A to point B when it hits the ground. Now what we can say here, whenever you have any question, first thing you decide like which equation you want to use. I'm using the equation which is s equal to ut plus half at square. The moment you write the equation, the second thing what you will do, you have to identify these value in the above equation. You are going to put it from x-axis or y-axis. So I'm saying I'm going to put the value from y-axis. You can already see the chart which I have given you above. So the moment you start plugging the value, every single value should be related to the y-axis. So what you can say, the displacement on y-axis, please focus on this part. The displacement on y-axis, I can say it is 0. My initial on y-axis, I can say it is u sine theta. My time of flight I need to find, then I will say it is plus half. The value of acceleration, I'm going to put it as minus g, and this t square is something which I wanted to calculate. The moment I read this equation, it becomes very simple for me to make my time as a subject. So I will take gt square by 2 to the other side. This is u sine theta into t. Cancel the value of t which is common on either side. Now you can simply say that in this case, if I have to calculate the time of flight, it can be calculated by 2u sine theta, and this g will go down. So this is how the formula is going to be look like. This is something logically you can connect when it comes to the projectile motion, and with respect to the table, You just have to be careful with the values. That's it. In the second case, suppose if we have to calculate like what will be the time of flight, means in how much time the object will reach the ground. Now look here, I'll show you this case also so that you will be able to relate over here. So I'm simply saying again, first identify the equation. So I will identify the equation. Let's say in this case, I'm taking the same equation, which is s equal to ut plus half at square. Try to understand one thing. After identifying the equation, you have to identify on which axis you are going to use this particular equation. So again, I'm writing, let's say, use it on y-axis. Now again, I will focus on this particular column over here. Now try to see something over here. I'm saying displacement, it is minus h. My initial value on y-axis, I can say it is 0. My value of a, I will say it is minus g. And the time of flight I wanted to calculate, let's say I'm writing it as t square. Now what is going to be happen over here? I can see that the t I can make as a subject, minus minus will get cancelled from the other side. You can simply write this equation that 2h, as 2 will go up, g will go down, and this is square. So take a root on to the other side. Look at this particular equation. If you have the value of h and g, and if you simply plug in this particular case, you will be able to find the time of flight for this particular case. And the same time can be used to calculate the distance covered on the ground as well. So you will be able to find your range as well. So point here is, when it comes to projectile motion, the questions are going to be very easy only if you are correctly able to identify that what exactly is the value given on x-axis and y-axis. Thank you.